places on Earth where stone no longer looks like stone. A boulder stands on a base so narrow that gravity appears to have forgotten it. A mountain rises from an empty plain with almost nothing around it. Thousands of rock columns fit together with such precision that they resemble the remains of an engineered road. And in the middle of a desert, one enormous block of stone has been divided by a line so straight that the first question almost everyone asks is the same: who cut it? But perhaps that is the wrong question, because Earth has been sculpting stone for billions of years. Long before humans carved their first monument, volcanoes were building mountains, rivers were cutting canyons, oceans were hollowing cliffs, ice was splitting rock, wind was carrying away individual grains, and beneath everything, continents were moving. Most of these changes happen too slowly for us to see. A human lifetime is almost meaningless to a mountain, but give nature thousands, millions, or even tens of millions of years, and stone can begin to look impossible. Today, we are crossing deserts, coastlines, mountains, forests, and volcanic landscapes to discover 20 extraordinary rock formations that appear to challenge everything we expect solid rock to do. And our journey begins with perhaps the most unsettling of them all, because this first formation doesn't merely look unusual, it looks cut. Al-Nasla, Saudi Arabia. In the desert southwest of Tama stands an enormous sandstone formation. From a distance, nothing seems particularly impossible. Then you move closer, a dark vertical line appears. It begins near the top of the rock and continues almost perfectly toward the bottom. And suddenly the formation looks less like geology and more like something produced by machinery. This is Al-Nasla. The massive sandstone block is roughly 6 meters high and about 9 meters across, divided into two sections by an exceptionally clean-looking fissure. Both sides appear to rest on relatively small natural pedestals. The combination is what makes it extraordinary. If the split alone existed, it would be unusual. If the pedestal alone existed, erosion could easily explain the strange silhouette. But together, they create something almost too symmetrical, and photographs only intensify the illusion. The two faces appear to correspond remarkably well. The gap remains narrow. The line appears almost vertical. There are even ancient petroglyphs on the formation, reminders that humans encountered this strange rock thousands of years before photographs carried it around the world. Naturally, this appearance has inspired extravagant explanations. But geology doesn't require a lost technology to split stone. Rock contains fractures and joints. Once a weakness exists, temperature changes, weathering, moisture, and erosion can gradually exploit it. Meanwhile, softer or more exposed material around the bottom can erode faster, producing the narrow pedestals beneath the larger mass. The precise history of Al-Nasla's striking fissure has been debated, but the formation shows the unmistakable effects of natural weathering and erosion. And that may be more remarkable than any exotic explanation, because nobody needed to cut the stone. Nature only needed enough time. Yet Al-Nasla is merely the beginning. Thousands of kilometers away, another rock seems to challenge an even more fundamental rule. It looks as though it should have fallen. Kummakivi, Finland, deep within the forests of southeastern Finland, an enormous boulder rests on another rock. But rests almost feels like the wrong word. It appears balanced, precariously, impossibly. The upper boulder is massive, while the visible contact beneath it seems strangely small. Walk around it and the illusion becomes even stronger. From certain angles, it looks as though one strong push should send the entire thing rolling into the forest. Yet, it remains. This is Kummakivi, a name often translated as strange stone, and unlike formations slowly carved into balance by desert erosion, Kummakivi's story leads back to ice. During the last ice age, enormous glaciers covered Finland. These glaciers were not simply frozen blankets. They moved, slowly, but with tremendous force. They plucked rocks from the landscape and transported them over considerable distances. When the climate warmed and the ice retreated, enormous boulders were left behind. Geologists call such transported blocks glacial erratics. Kumakivi is understood as one of them. The glacier carried the boulder. The ice disappeared, and the rock remained in an arrangement so improbable that thousands of years later, it still appears freshly placed. The forest eventually grew around it. Moss covered nearby stone. Trees rose toward the sky. Generations passed, and Kumakivi stayed exactly where the vanished ice left it. Sometimes the most mysterious thing about a rock isn't how it formed, it's how it arrived. But in North America, another formation doesn't merely balance above the landscape. It rises from it like the remains of something enormous buried underground. Devil's Tower, Wyoming, United States. Across the plains of northeastern Wyoming, the horizon suddenly changes. A gigantic column of rock rises more than 1,000 feet above the surrounding terrain. Its sides are steep. Long vertical grooves run down its surface, and from a distance, it looks almost like the stump of an impossible prehistoric tree. This is Devil's Tower. Its strange appearance comes from igneous rock formed from magma that cooled underground. As the molten material lost heat, it contracted. Fractures developed. The result was a spectacular system of column-like structures. But what we see today required another process. Removal. The surrounding sedimentary rocks were less resistant. Over immense periods, weathering and erosion stripped them away. Streams cut downward. Rain attacked exposed surfaces. Freeze-thaw cycles weakened rock. Gradually, the harder igneous body was revealed. The tower did not suddenly rise. The landscape around it slowly disappeared. But geology is only part of this place. Devil's Tower is culturally and spiritually significant to numerous indigenous peoples. And traditional narratives associated with the formation long predate modern geological interpretation. That distinction matters. A landscape can possess a geological explanation without losing its cultural meaning. One tells us how stone formed. The other tells us what a place has meant to human beings. And sometimes, those stories have survived far longer than written records. From one giant tower, our journey now moves to an entire coastline made of columns. Thousands of them. And this time, their precision becomes almost mathematical. Giant's Causeway, Northern Ireland. Along the coast of County Antrim, the ground breaks into thousands of stone columns. Many have 6 sides, others have 4, 5, 7 or more. Together, they form steps descending toward the Atlantic. From above, they resemble an enormous pavement. From the side, they look like the pipes of a gigantic stone organ. This is the Giant's Causeway. Approximately 40,000 interlocking basalt columns occupy this extraordinary coastline. Created by volcanic activity roughly 60 million years ago, the geometry comes from cooling. As thick lava cooled and contracted, fractures propagated through it. Under suitable conditions, those fractures organize themselves into polygonal patterns. Continue the cracks downward and the polygons become columns. Nature had produced geometry without measuring anything. But for centuries, another explanation was much more entertaining. Irish folklore connected the landscape with the giant Fionn McCumhale or Finn McCool, and a legendary confrontation across the sea. Science eventually explained the basalt, but the legend remained. And standing there, it isn't difficult to understand why giants entered the story. The scale almost demands them, yet volcanic cooling can create far stranger forms than columns. In Turkey, ancient eruptions produced a landscape where rocks appear to wear hats. Fairy chimneys of Cappadocia, Turkey. At sunrise, the valleys of Cappadocia begin disappearing beneath balloons. Hundreds can rise into the morning air, but beneath them is the real spectacle. Stone towers emerge from the valleys. Some are tall and narrow, others are conical. Many support darker blocks of harder rock on top, giving them the appearance of enormous chimneys wearing stone caps. They are the famous fairy chimneys of Cappadocia. Their story began with volcanoes. Ancient eruptions spread ash and volcanic material across central Anatolia. Much of this material eventually consolidated into relatively soft tuff. Harder volcanic layers occurred above portions of it. Then erosion began. Rainwater entered weaknesses. Wind removed particles. Valleys deepened. Softer rock disappeared relatively quickly. Where harder caps protected the material beneath them, towers survived. The result is a landscape that looks constructed, and humans took advantage of it. People carved rooms into the relatively soft rock. Homes appeared, storehouses, chapels, monasteries. Entire underground complexes developed elsewhere in the region. Nature created the architecture. Humans moved inside. And today, the boundary between geological formation and human construction can become difficult to recognize. But if Cappadocia resembles a city built by erosion, our next destination resembles an ocean that suddenly turned to stone. Wave Rock, Western Australia. Imagine an enormous wave approaching the shore. Its face rises, the water curls. Then, just before breaking, time stops. That is the illusion created by Wave Rock near Highton in Western Australia. The formation is part of a much larger granite body. Its sweeping curved face resembles a giant frozen wave, complete with vertical streaks produced by mineral staining and water movement. But there was never an ocean wave trapped in stone. The curve developed through prolonged weathering and erosion. Processes acting around the base of exposed granite helped create the undercut profile. Later, as surrounding material was removed, the curved surface became increasingly exposed. Rainwater moving across the rock carried dissolved materials and contributed to the colored streaks that make the wave even more convincing. The illusion is so effective because our brains recognize the shape instantly. We know what a breaking wave looks like, and when stone copies that geometry, the mind struggles to separate motion from permanence. But Australia contains another rock whose shape is less important than its sheer isolation. A single mass rising from a landscape so broad that distance itself becomes part of the monument. Uluru, Northern Territory, Australia. The first surprise is its size. The second is its color. And the third is realizing that much of the story lies beneath the surface. Uluru rises dramatically above the plains of central Australia. Its red exterior changes with the angle of sunlight, appearing deeper, brighter, or darker as the day progresses. But Uluru was not simply a giant boulder sitting on the desert. It is the exposed portion of a much larger rock body. Its sandstone originated from sediments associated with ancient mountain building and erosion hundreds of millions of years ago. Those sediments accumulated, were buried and lithified, and later tectonic forces tilted the layers dramatically. Then erosion removed enormous quantities of surrounding material. What remained became the monolith visible today. Its red color comes largely from oxidation of iron-bearing minerals near the surface. In a sense, the rock is rusting, but any account of Uluru that treats it merely as geology misses something essential. Uluru is deeply sacred to the Anangu, the traditional owners of the land, and its features are embedded within living cultural traditions. The formation is therefore not simply something to look at. It is part of a cultural landscape, and that changes the meaning of the word wonder. Sometimes extraordinary does not mean unexplained. It means a place contains more than one kind of truth. Far away in the American Southwest, however, another formation earns attention for a much simpler reason. Its enormous upper mass appears to have chosen the smallest possible place to stand. Balanced Rock, Arches National Park, Utah. The road through Arches National Park passes landscapes already crowded with impossible shapes: stone fins, natural arches, cliffs, domes. Then one formation appears almost comical. A gigantic block seems perched on a narrow pedestal. Balanced Rock. From certain viewpoints, the upper rock appears detached, as though someone placed it there. But the formation is connected. The apparent boulder is composed of harder sandstone sitting above a more easily weathered supporting layer. Over time, Differential erosion removed material around the base more rapidly. The upper section survived. The pedestal narrowed, and the formation became increasingly dramatic. Yet balanced formations contain their own warning. They are temporary, eventually weathering winds. Other nearby balanced rocks have already collapsed. One day, geological time will claim this one as well. That is what makes formations like this strangely compelling. We are not seeing the final product. We are seeing a temporary stage between a cliff and rubble. A moment that may last thousands of years, but still only a moment. And nowhere is that temporary architecture more spectacular than in a landscape filled with thousands of stone towers. Bryce Canyon hoodoos, Utah, United States. They stand shoulder to shoulder like a silent crowd. Thousands of narrow pillars rise from enormous natural amphitheaters. Orange, red, white, pink. Some are topped with harder caps. Others taper into delicate points. These are the hoodoos of Bryce Canyon. Despite the name, Bryce Canyon is not technically a single conventional canyon carved primarily by a river. Its famous amphitheaters formed largely through weathering and erosion along the edge of the Poundsaugend Plateau. Water enters fractures in the rock. Temperatures drop. Water freezes. It expands. The cracks widen. Repeated freezing and thawing gradually break the rock apart. Rain also helps dissolve and remove material. Fins develop. Windows can open within them. Eventually, sections separate into individual pillars. Hoodoos are born, but from the rim, geology disappears behind spectacle. Thousands of towers fill the landscape. Sunlight enters between them. Shadows move across their walls. Snow sometimes settles on orange stone, and the entire amphitheater appears less like erosion than the ruins of an enormous city. Yet even Bryce begins to look almost orderly compared with our next landscape. Because in Madagascar, stone becomes a forest of knives. Tsingy de Bemaraha, Madagascar. From above, it resembles a gray sea frozen during a storm, but the waves are sharp, extremely sharp. The Tsingy de Bemaraha landscape of western Madagascar contains extraordinary limestone pinnacles separated by deep fissures, caves, and narrow passages. In places, the stone is so jagged that moving through it can become extraordinarily difficult. The name Tsingy is often associated with the idea of terrain where one cannot easily walk barefoot, and one look explains why. The formation developed in limestone. Water gradually dissolved the soluble rock. Fractures widened, channels deepened. Underground drainage systems developed. As dissolution continued, portions of the limestone were carved into narrow blades and towers. What emerged was one of the most extreme karst landscapes on Earth, and isolation within this maze created another consequence. Life adapted. Madagascar is already famous for endemism, and the Tsingy contains habitats separated by cliffs, caves, and pinnacles. Forests survive between stone walls. Animals move through narrow ecological corridors. The geology doesn't merely provide scenery, it shapes where life can exist. Here, rock became habitat, but across the Indian Ocean, erosion created formations that look far less threatening. They look almost like giant mushrooms. White desert rock formations. Egypt. At first, the landscape seems covered in snow. Then the temperature reminds you where you are. Egypt's white desert within the Western Desert contains extraordinary pale formations rising from the sand. Some resemble mushrooms, others resemble animals, domes, towers, abstract sculptures. The material is largely chalk and related sedimentary rock, remnants of ancient marine environments from a time when this region looked nothing like the desert of today. That fact alone transforms the landscape. This intensely dry place preserves evidence of an ancient sea. Over immense spans of time, wind and weather attacked the exposed rock. Softer portions disappeared faster. Harder sections remained. Sand carried by wind acted like abrasive material, and gradually, familiar-looking shapes emerged. but the resemblance to animals and objects comes partly from us. The human brain is extraordinarily good at finding recognizable forms. Give us a strangely shaped rock, and we see a rabbit, a chicken, a mushroom, a face, a castle. Geology provides the raw shape. Imagination finishes it. Yet there is another desert where stone towers are so immense that they no longer resemble sculptures. They resemble skyscrapers. Wadi Rum, Jordan. The desert opens, then the walls begin. Across southern Jordan, enormous sandstone and granite mountains rise from wide valleys of sand. This is Wadi Rum. Its formations are gigantic. Natural arches cross empty space. Canyons narrow into shadow. Cliffs tower above desert floors. Weathering exploits fractures within the rock. Wind removes loosened material. Occasional water becomes disproportionately important in an arid environment. Temperature changes place stress on exposed surfaces. Grain by grain, the mountains are dismantled. But at human scale, they appear almost indestructible. And humans have moved through this landscape for thousands of years. Rock inscriptions and petroglyphs preserve traces of earlier travelers and communities. Bedouin traditions developed within an environment where understanding terrain, water, and distance was essential. That human presence gives Wadi Rum a different character. The landscape appears empty only if you don't know how to read it. A canyon can indicate a route. A rock face can preserve history. A spring can determine survival. A mountain can become a landmark visible from enormous distances. At sunset, the sandstone changes color. Orange becomes red. Red becomes purple. Then darkness removes almost everything except silhouettes. The desert suddenly seems endless. But our next formation was created not by desert wind, but by an ocean repeatedly striking the same stone. 12 Apostles, Victoria, Australia. They stand offshore like abandoned towers. Some are tall, some narrow, some visibly fractured, and each one exists because the coastline behind it is slowly retreating. These are the famous 12 Apostles along Australia's Great Ocean Road. Despite the name, the number of prominent stacks has never remained permanently fixed at 12. That is because this landscape is changing. Waves attack the limestone cliffs. They exploit cracks. Caves form, caves enlarge. Eventually, openings can break through headlands to create arches. The arches widen, roofs collapse, and isolated pillars remain offshore. Sea stacks. But the process does not stop there. Waves continue attacking them. Weather weakens them from above. Eventually, stacks collapse as well. So when we look at the 12 Apostles, we are watching multiple stages of coastal destruction. Cliff, cave, arch, stack, rubble. The beauty comes from erosion, and erosion guarantees the beauty will not remain exactly the same. That paradox follows many of Earth's greatest landscapes. The process creating them is also the process destroying them. But sometimes erosion works from underneath rather than from the side, and when it does, entire mountains can become hollow. Marble caves, Patagonia, Chile. Across the turquoise waters of General Carrera Lake, stone begins to change color. Gray becomes blue, blue becomes white. Curving walls reflect the water beneath them, and inside the cliffs, waves have opened chambers of polished stone. These are the marble caves of Chilean Patagonia. The formations consist of marble that has been sculpted by persistent wave action and dissolution along the shoreline. Water entered weaknesses. Waves repeatedly struck the stone. Over long periods, cavities expanded, passages formed. Walls became smooth and curving, but the extraordinary color is partly an interaction between rock, water, and light. The lake's brilliant tones reflect upward onto pale marble surfaces. As water level, weather, and sunlight change, the caves can appear different. The stone seems blue, then gray, then almost turquoise. Nothing has changed in the marble itself. The light has changed the way we perceive it. That makes the caves feel alive. Water created them, and water continually changes their appearance. Yet in New Zealand, another enormous stone formation is remarkable because water and erosion seem to have produced something almost architectural. Moraki Boulders, New Zealand. At low tide on Kwekohe Beach, Enormous spheres emerge from the sand. Some are almost perfectly rounded. Others have cracked open, revealing complex internal patterns. Scattered across the beach, they look like giant eggs abandoned by something prehistoric. These are the Moeraki boulders. Unlike ordinary beach rocks, rounded simply by being rolled in surf, these boulders originated as concretions, minerals precipitated around nuclei within ancient seafloor sediments. Layer by layer, material accumulated. The concretions grew. Sediments around them eventually became rock. Much later, coastal erosion exposed the boulders. The cliffs retreated. The surrounding mudstone disappeared, and the harder spherical concretions were released onto the beach. That sequence reverses what the ice suggests. The ocean did not roll ordinary rocks until they became enormous balls. The spheres largely developed within sediment long before the modern beach existed. The sea merely revealed them. Some are fractured. Those cracks can contain mineral deposits that create polygonal patterns inside the boulders. It is almost as though breaking one open reveals the geometry hidden beneath the smooth exterior. But across the Pacific, another landscape turns geometry into something much larger. A canyon whose walls seem to twist like flowing fabric.